this without shuffling. Yeah, much better. Hey, sound is good. Hey man, thanks. Alright, I guess we should get going. So, for today, I wanted to show you again the Hawaii project. This is already the 7th part of this stream series. But I've made some really huge progress, and I wanted to share with you what I've been, how far it has gone, because it's getting really good. Still some edge cases left here and there, some edge cases to be ironed out, but for the most part it's getting good. And I wanted to show you the samples. So right now I'm adding samples to the repository or other repositories and show you how to work with it. So let's give it a try. You could try it as well. You could try it as well on your machine. This is all just it's all public, so you could just go .NET tool install -g y if you want to install it, but I don't want to install it because I already have it, so I'll just update it and see which version I am on. Alright, there you go. I am 0.29. Alright, let's go to the sample because I have the sample right here. The minimal pet store sample. And it's basically a console application where the pet store is generated by Hawaii, and here we have the configuration. So just let me go there. I think it's projects and pet store tests. Open up code. Let's look at the generated files. Alright, so that's my console application. I have a program fs, and it's referencing the generated project in the pet store. That's this project in here, and all its files and dependencies and everything. So if we look at the configuration, I have the schema that I'm using right now, which is the canonical standard pet store schema. This is v3. The name of the project will be pet store. That's why the project file is also called pet store. Where it should go in the pet store directory, which is relative to here. And the functions that I want to create should be synchronous. So if I go Hawaii, I don't do anything. That's literally the only command you need for generation. It will basically delete and recreate everything. And yeah, it deleted and created everything. It looks like the project file has changed because I just updated Fable remoting JSON. There was a small bug in there of when int 64s were getting overflow exceptions. So I got that sorted out. I just published it, and we get the new version. So let's look at the program file, which is the thing that uses this reference file. So when we have this project referenced, we get mainly two namespaces. Well, there are a couple more, but these are the ones that you use when you reference the project. You have the main namespace, which exposes the client, and the types namespace, which exposes the types used by the client. So what we do is first we construct a URI to the service root. I don't want to play Counter-Strike right now, maybe later. You basically have a URI to the base URL, and then you create an HTTP client from that base address, and then you give the pet store client the HTTP client, which then it uses it underneath to make the calls. So now if we look at pet store dot, we could see there we have it, all these functions that are exposed by the pet store API. And what's interesting, I think last stream I was working on making the unions for the responses. Those were these things. Let me see. So we have the types here, But more than the types, we also have these unions which describe the possible responses of each operation. So here we have add pet, which is, and this is the response that has either OK or method not allowed. And in case of OK, you will actually get a pet back if everything is good. Same with update. It basically maps all possible responses that are defined by the schema into a nice union, and that becomes the output of the function. And these are just the global types defined by the schema. So this is really nice. I'm really happy with this. I've added a really nice thing where if a method like this one doesn't define a 200 case, basically. So basically this operation, update pet with form, says the only response I give you back is method not allowed, which is a bit weird because there must be some kind of OK case, right? It doesn't always return method not allowed, I think. So in case where it doesn't have an OK response, I will give it a default response. Delete pet, upload file, get inventory. I'll show you in a bit what that does. And here the return type is actually a dictionary. So yeah, all these things map to output responses. And if we look at the client, we will be working on this today, I think. This client is made specifically for F#, like on .NET, not on Fable, because it uses the HTTP client. HTTP client is something that Fable does not understand. So we'll have to replace the Http runtime, the HTTP bits, to use something that Fable does understand, and see how far we can go. But basically, this is the generated client. It's really nice. It takes all the documentation from the server definition, like here, and you could browse it like this. And then from each operation, what it does for each operation, it basically, after it defines the parameter, it collects them into this array, this list of request parts. Some of the request parts will be just like a JSON content, like the JSON body, but some other parts will be in the path or in the header or in the query, etc., etc. And then we call this function OpenAPI http.put, and it gets us an HTTP status code and content back, which is of type string. And then it generates this kind of decision tree to map the status code to responses. So here, for example, it checks if the status is OK, it returns update pet OK, but it doesn't return you the content directly. It deserializes it to pet. So that's really nice. So for content, because it knows it has to be of type pet, it applies the deserialization. If it was just string, you would get this. But this doesn't work because OK expects a payload of type pet. So yeah, this is what it generates. I'm quite happy with it because, like I said, I started this project because you cannot generate unions and records from the type provider, and that's why I wanted to do this from scratch, because we will be basically like not restricted with anything. The only restriction we have here is just the language F# itself, and we're able to generate everything we want, unions, and use them really in a really nice way. So I'm really happy with this. Let's see how we are actually using it again. So after I've generated a client, I can actually start using it. So I say find pets by status and give it this status where status is available. This is again a nice thing about this generator. This is, I think, the very first thing that I created at first, which is generating these enums. These are nice here, but sometimes they can get really complicated. I think I would need to have an option to whether or not generate these enums, but for now they're doing fine. Unless they're really weird, or sometimes they will write out not make the project compile because they're so weird and they're not properly sanitized. I'm doing all kinds of cleaning of the enum cases to make sure they're valid F#, but I might have missed some case here and there. So that's still something I need to work on, but you know, it's a small thing. So yeah, I find the status and it's available, and then I make I format it. So this is a string status, and then I give it to this function, and I can match against all responses. If I get a bunch of pets, I can, for each pet, I can print the name. Another thing which is really cool is if I have a single case result, like the get inventory, it only has OK, which is, I guess, fine. I can extract the inventory right away and then do something with it. So that's really cool. Let's run it and see if it works. If it doesn't, then I might have messed up something along the way. Come on. Hey, there you go. So here we're getting the names of the docs because that's what I'm printing here. And finally, I'm getting the statuses and the quantities. So there are quantity, pets, and then the status pending, approved. I guess I should say pet orders because it sounds a bit cruel like this. Pet orders. Well, a pet store already sounds a bit shady, but okay. Let's see. So yeah, this is pretty much the initial. Well, not the initial. I've been fixing quite a lot of bugs in here. But yeah, that's basically the initial F# client. So basically, this works for F#. You could use it from a console. You could use it from the backend. You could use it anywhere F# is used because this thing generates a net standard project, and it uses this for serialization, which is again just F# on .NET. So with that in mind, what I want to do today is take this client and try to generate something that Fable understands. So basically removing all of these things and start using things that are F# specific. Also things like this. Because again, Fable doesn't know about HTTP status codes, it knows 200. So I think I'll start with that. So this is the intro. This is the project so far. I'm really happy with it. I've been adding actually some really nice options to it. So let's go to the options. If you go here, you will see that you can, I think I've shown you this before, you could say what type of async return type you want. So you want async, like the F# async or the task. Resolve references is a bit a weird one. It's sometimes you have like a workspace document of OpenAPI schemas. You don't have one schema, but you have multiple schemas, and they all have parts of their definitions scattered about. And this one will try to kind of load everything and try to match up the parts. It does quite complicated stuff. I don't think anyone is using it right now, but it's there. There's the empty definition option. I don't think we will need that for now, but there's an interesting one here as well, which is the override schema. Override schema allows you to put a piece of JSON in here that will be merged into the OpenAPI schema that you chose, and that will override basically the original schema. You could do this to basically it's an escape hatch if you know the schema is wrong, or you can somehow make it better, or make it return strings instead of, I don't know, XML. You could do these things. Sometimes the operations won't have a name, they will be missing. I will try to figure out what the name should be based on the path and on the method. So if this didn't have a name, it will be put pet, which is, I guess, fine. But sometimes you could get clashes. So if this generates the same thing as this, then that's another reason why you would want to override the schema. It's just an escape hatch. If the schema is good, you shouldn't be needing to do this, but it's good to have there anyways. It's good to have anyways, and there's documentation how to There are examples of how to override the operation IDs, how to override the response types from the content. So yeah, that's going really good. Of course, we still have the limitations of Fable support and any of one-off. We will not be looking at those today, but I want to look at the Fable support today. So with that, let me just open up the main project. Should I leave this here? Nah, it's okay. Let me see. Go to Hawaii, open up the solution. I'm going to Visual Studio because Ionide is having just a little bit of trouble keeping up. Because I think I've been... Okay, I'll just show you in a bit. Let's see. Video is good now. Smooth is better. Thank you, Jason. I had a go at using the override workaround a couple of bits. Incorrect schema seemed to work. Okay, nice. That's why I've added it. But if it's also something that like Hawaii should be able to resolve on its own without you having to override it, then you should maybe file an issue and let's see how we can fix that. We're already fixing quite a bunch of those, right? It's good to know that the video is good now, because last time I had a video and I was talking. I talk a lot throughout these things, and I was talking for an hour and a half, and there was a noise every time I spoke. So that's a noise the entire video. I don't think that was nice to look at. And I don't make these videos often, so at least when I make them, I want it to be at least listenable in that case. All right, you will see why Ionide was having trouble, because I'm writing code relentlessly and I forgot that files exist, so I'm just writing everything in program FS, which is quite cool because I hadn't had the need to use more files. I'm just adding more functions on top of each other. So write a function. If I need another one, I need a type, I'll just write the type. I need another function, okay, I'll just write one above it. Or I need more types like these, basically. I'll just write them here. I should probably break things out. The code is not as beautiful as it could be. There are some refactoring opportunities here and there. For example, you might have seen this a couple of times throughout the code where I shouldn't have duplicated it. But who cares now? It's just it's just about the generated code. It's about what it generates right now. If I make sure that the generated code looks beautiful, I don't care too much about the actual generator, because these expressions could get really wild. Like this is the pattern to generate the what do you call it? I think this is the pattern to generate the parameters for the create functions. Okay, so what I do have here is two projects. The build project is to automate my work, so I automate the building, the packing, the publishing. I have a couple of integration tests, and I also have a rate function. The integration test will basically take the first 20 schemas, 20 public schemas from the API Guru list catalog, and generates and builds the projects. And rate first n projects will actually so the integration is all or nothing, basically. So I run the integration tests, and if anything fails, then the whole thing fails. But the rate thingy will run will generate the first n projects and see how far it goes. So I think I had the report from the very last one. Was it Hawaii 5? This is from I think from a week ago. I ran it against, basically I let it run through the entire night, and it was able to generate about 80%. About 80% from what it should need. Is that 80%? Wait. That's a bit more than, well, 10% is 150, 300. Yeah, that's a bit more than 80%. So yeah, this is really, really nice. Of course, I don't actually test the runtime. I don't make requests to these APIs. But I just like build a schema, build a project, and see if that works. Of course, I need to check the runtime more, but you know, this is I'm really happy with this. Maybe today it will be more, because I started very low. Let me see, the very first one, 2. Well, yeah, that wasn't really good. But then I started taking each one of those and then trying to figure out what issues I come across and fix those and see how it goes, etc., etc. So yeah, that's quite nice. You need a generator. I absolutely do. They're getting out of hand these days. I'm already thinking about the next one, but let's see how far I can go today. All right, so this one is pretty interesting. Yeah, it's basically the entire thing, right? So we have parameters. Yeah, it's a bit ugly, but that's fine. Can I unfold? I don't think Visual Studio knows how to fold or unfold these when it hasn't loaded it. Let me build. Maybe that helps. Build. So yeah, I've done also some work around responses that contain binary outputs. So if you have, for example, an endpoint that returns you a file in the OK case, but returns you some other thing in the other cases, so it returns you text or JSON or something that needs to be deserialized, it knows how to work around that. So this one is, I'm really happy with this one because I haven't seen any solution that works with these. I've been looking into other generators, OpenAPI generators. I haven't found anyone that was impressive so far. So that's what. So I was like, okay, that's really cool. Okay, so here is the bulk of the stuff. Yeah, this is where we generate the client, and this is where I will need to make changes based on the config, because I have the create OpenAPI client function. It takes the configuration, it takes a document. I'm keeping track of an array of visited types, a resize array, because I don't want to generate types that were already generated. There's like there's a mechanism to deterministically add new type names if they were already added, especially when generating the global types, but that's not a problem here. Couple of problem will be, okay, so the request values can stay as is. Which HTTP function we'll be using, one for binary and one for async, we will keep using that. So this is the HTTP call. We have the wrapped return. If the config is synchronous, then we just return the expression. If it's not synchronous, then we have to have a return keyword. We have to have also equality in here, left, right, and then the return expression, and then the decision tree, which looks like this. I haven't found a way to like make a smart function to do this like for n responses. So right now it just works with 6 responses. Yeah, that's right. Because I'm just too lazy to make something really nice. I just want to make something that works first, and then make something really nice. So we could already start doing things based on the configuration. Okay, so the async builder will be if synchronous is expression, otherwise if it's async then create async, otherwise create task. We could already start doing things with Fable because we know Fable doesn't allow task or synchronous. So if Fable target is target Fable, then that will be the async one. Else then start looking at these things. So that's the async builder, because we know Fable doesn't do anything with tasks and cannot allow asynchronous requests. Well, it kind of can, but it's not recommended, and we shouldn't do that. So that's this. So that's the first one. I will also keep looking at the generated file. So let's see, source output code. When I explore the files in a directory, I work with code more than not. I can also show you what it generates. So if I go to Hawaii, so I can show you what it generates right now while I'm working on it. Let's not use this. Let's just use the pet store. Let's take basically this. Actually, I've already have some logic to provide the target via the configuration, but I haven't had the chance to document it because I want to document it once it's finished. So now when the target is Fable, let's generate the pet store. I only need to do .NET run. .NET run. That should do it. So now, regardless of whether synchronous is enabled or not, I should get a Fable project. A couple more things that are already in place for Fable are, for example, the packages, the installed packages. So here, if we say if the target is F#, then I want remoting JSON and Newtonsoft JSON. These work together. But if the target otherwise, which is Fable, then I will get simple JSON and simple HTTP. Simple JSON for deserialization and serialization. Simple HTTP is for the HTTP runtime, which means that I still need this file. I only need the string enum when it's on F#. What else? Yeah, let's see. So client doesn't work because it's referencing HTTP, but HTTP wasn't included. So let's run that again. If you have any questions about what I'm doing or why I'm doing it, just let me know. Let me know in the chat. I will look here every now and then. All right. I just hope that the .NET run would run a lot faster, because I think because I'm streaming and recording, it's taking a toll on my machine. Okay, it's generated it. Hey, why don't I see any project in here? Ah, there you go, because I didn't write the file. So basically, I need to say else the HTTP library, which is now still not Fable compatible, is async return type. This will be async, and write that down. Okay, run it again. So now we will also, oh no, that's a boolean. Library will take false. There you go. You see, Visual Studio is so slow that it sometimes delays the save. Now it should work. I think it locks the files while it's building. Okay, so now we should get the OpenAPI HTTP, and we will have to kind of see what changes are needed there. All right, there you go. Now it has the OpenAPI HTTP. Everything is the same, which means it still doesn't work because HTTP client doesn't work. Now we get the async anyways. So even if we have synchronous enabled, this will still work. Request parts will be the same. But async will not need the client anymore. Yeah, it doesn't need the client. and status should be a number. So let's look at that. So if I go to pet status, yeah, all these helper functions will stay the same. Okay, those will change. Let's see. Yeah, send async won't be needing this. Oh, as you can see, I also have simple HTTP and simple JSON in here, so that's great. The client doesn't work. Okay, let's start making changes here. So we won't be needing remoting JSON. We won't be needing system.net. We won't be needing globalization, and neither we will be needing system.text. Instead, we'll be needing Fable, simple JSON, and Fable, simple HTTP. Okay, still has it loaded, but that's okay. Okay, I don't think I need to work on the runtime right now. Let me just copy this. Go to the HTTP library, which is basically the string that gets spit out when you generate the stuff. What's this? This is content, and then I'll need library content. Fable content. Okay, that's my Fable content. Namespace will be project name. And I don't need to do any of these because everything is async. Yeah. Okay, serialize is JSON serialize value. Of course, because we are in Fable and we're using generics, then we need to inline those things. Because if you don't inline, you lose the JSON parse native as T. If you don't inline, then you lose the reflection metadata. We don't need those things. Okay, that's our serializer. Those things can stay the same, and then the HTTP runtime will be different. Serialized value. I guess I will just cheat because it's fine if we do it like this. String value. String value. I guess it's fine if I just do this. Okay, apply path parts. Apply query string should work except for this part. We'll look into encoding and decoding later. Apply JSON content. Apply binary content. Don't know how to do that yet. Apply headers. Again, I don't know how to do that yet. So I'm just gonna see which parts are applicable and work my way from there. Okay, async, send async does not need this. It does not need, well, it does need a method. HTTP method. Okay. Let's just assume that this returns async int and string. Let's just assume that for now. And that will be fail with not implemented yet. Okay. Send binary, still don't have it. Get async. will not need get async. We don't need the synchronous version. We don't need the binary version. Okay, so for now, post async, get async, delete async, and delete binary. Okay, so that is it for now. Binary, patch binary, there you go. I guess we'll do this one as well. All right. None of these take HTTP clients. Right, they don't take any HTTP client. The send async one neither. But they do get the method. So with the method, the path, and the parts. So far so good. Let's Fable library will take the project name, right? We'll take project name, which is a string, and then takes the Fable content and replaces the project name with it. Okay, so that's Fable library. If I can spell it, of course, so that's project name. And inside of the program, I will need Fable library, and then write it out here. Okay, let's run this thing and see what it gives us. Okay, I'll go to the interesting bits now, because I don't think you want to see me write F# in a string. Let's see what that gives us. Okay, that's better. I still need those things: JSON serialize, parse native as. Okay, doesn't know about HTTP method, because that's interesting. I want to know what how simple HTTP does it. Let's see. So if I go Fable simple HTTP, it totally forgot how the methods were defined. Oh, just like this. But what is it? What's the name of the type? Maybe it's just good. Let me just build it. I don't want to change anything. It should build, even though like I have not implemented here. Okay, it doesn't. HTTP is not defined. Constructor gets. Maybe you want the following. Yeah, that's the thing. Fable. Come on. Simple HTTP. Dot. Is this it? Or was it not defined exactly? Okay, maybe that's just ionite choking. Let's reload. Yeah, it is HTTP method, so why did it tell me that it wasn't implemented? Yeah, it's good now. Patch, head, git, post options. Okay, so I just need to capitalize those and I will be good to go. Okay. Okay, that should be easy. The head, patch, put. I don't have delete binary async. Delete. Post and get. Okay, that should do it. And what I need to get from those is of course the int and the string. And those ones were resolved correctly, so that's serialize. Alright, is it still not good? Why? Yeah, no, it's good. That is nice because I just removed the parts that don't work. Okay, we still need to implement send async, but I want to implement the runtime later. Right now, I want to fix what I know how to fix, which is the client. So put async will take the path and the parts without the HTTP client. So we need to remove this parameter in the functions. So if I go back to create OpenAPI client, this identifier won't be needed. So if the HTTP call, if config target is target Fable, F#, then this thing. Okay. Only use the HTTP client F#.net clients. I will still need the full path and the request parts. So that's good. I won't be needing this one. Next up is the implicit. Is the implicit constructor? Where is it? These are the parts, responses. The implicit constructor, where did I define it? Client operation. Yeah, I'm opening the types here. I don't need to open up anything else. Yeah, there you go. Implicit constructor of HTTP client. So this is HTTP client, and what I need to do is, instead of getting an HTTP client as input, what I need is just the URL. So I need URL of string in here. And I think later I need to have a header list. Headers or default headers, which will be a header list from simple HTTP. But that's for later. Let's start now just with the pet store client URL. So URL constructor param will be a type thing where it's called URL. It's of type string. So if can I add another implicit client? What happens if I have both of those? Let's see, if config target is target F#, then I want this constructor, otherwise I want the other constructor. Okay, so now I don't have HTTP client anymore, which means I also don't need the opened namespaces. Okay, let's see what it generates. So far so good, huh? Yeah. Who needs compiler help anyway? You know, right? Okay, so to hop off in 10 minutes. Looking forward to watching the rest on YouTube. We'll definitely upload this on YouTube when I'm finished. Thanks a lot for joining. See you around. Okay, we've generated the pet store. Let's see how it looks like. And now we're getting to the interesting bits. Okay, there you go. We are generating pet client. It takes a URL, a base URL. I think I still need to provide the base URL here because it should be like this. Yeah, I think I need to still provide a base URL to the functions. Let's see, not the responses, not the destructure. The destructure code still works. Yeah, the constructor is fine, but not the function. So if I go to HTTP library, I need path and I need base path string. And I need this across the stuff. So the base path will be everywhere. Okay. Base path. And just like that. Yeah, now that looks fine. Now I need to apply it in here. In the HTTP call, it was this one, right? Yeah, if the target is F#, else then I need to apply the base path to the generated functions. Okay, so that will be a URL. Create identifier, run the thing, and see what we get from here. Now I should see URL in here. I won't save it. I will let it generate. And next up is trying to get rid of those. Trying to get rid of those thingies. Hey, URL. It hasn't been updated. I think I need to refresh. Oh, did I just send async? Takes, oh, it takes the method first, then the base path. Okay, we can fix that. It's indeed not ideal to do this inside of a string, but you know, it's fine. It's not a biggie. Delete post goes here, get goes here, and we should be fine now. Okay, so that's one thing. I am generating URL, as I can see, so that's great. Next up is those status codes because they're cool, but my status is just an integer. So put async returns an integer and string. So I need to check against these numbers. All right, let's see how I can do that. So where is the equal used? Equal is used of equality. Yeah, status code equals, that's this thing here. And status is a string. Okay. Let's create equality expression for a status. For a number, basically. For a number. Well, let's see how many we can have. Status code is match status with, well, is it okay? Or is it like this? I think I can match it against name of HTTP status code. Okay. And that goes to 100 by 0. That work? Hey, that does. Okay, give me a couple of those. If it's bad requests, what's that, 400? Unauthorized is 403, 401. Not found is 4. Let me check. Yep. Method not allowed. Method not allowed is 405. We also have, okay, just a couple more. I think I'll have to exhaust those later. No content is no, and then created. Or created, that will be 201. Otherwise 0. So if config target is target F#. Yeah, Visual Studio is definitely not keeping up. If it's F#, then you keep doing what you're doing right now. Otherwise, then I need to make an equality between two expressions, where the second expression is not an identifier, but it's a constant. So I think it's thin expression. Come on. And I need a create const. Okay. And that will take sin const at say int32, which takes a number. That number will be status as number, will be the status code from the status. Will be this number. Does need a range, right? Oh, it is already the number. I don't need to. It's not a function. It's just a value. Okay, so now it will check whether status is equal to those numbers. Okay, let's look at it. Okay, let's hope everything is working from here. Still one error. Oh, I missed one. Did I? I got to base path twice. Okay, fine. Let's look at the client. Hey, that's more like it. Was async also wrong or what? Oh, it's fine. That is a lot more like it. Checking the statuses. It's a number. Not found. Bad request. I do want to keep those in because those are still nice. I don't want to change anything on the types really. The types are already, the types can be already deserialized perfectly. So no problem there. Okay, that was faster than I expected. This is already quite good. Okay, what I don't have still is of course the implementation for the HTTP runtime. And I also need to have a couple of Fable specific parameters. So for example here, upload file, it takes a byte array as request body, and it's binary content. I'm not sure if this should be, for example, file from the browser, from browser types. I'm not sure if I'm able to do this here, so that we could actually use these functions from file inputs. So I need the browser types later. But yeah, that's for later. I'll worry about binary responses later on. I think byte array also works fine. You just have to convert the file into a byte array, which is a uint8 array buffer, an unsigned byte array buffer, but that's for later. And the content is getting deserialized correctly. So I think we are good. We're good so far. Okay, let me see what happens if I switch back to sharp, or just complete. What happens if I say it's synchronous? It should stay, just stay as is. Synchronous. It's more like it. So .NET Run. It should stay on the async part because it's Fable. Oh, okay, that's the return type still. We lose the return keyword in the synchronous part. Okay, let's fix that quickly. That is the return expression, which is, well, wrapped return. If it's synchronous and not Fable, it's not target Fable, then well, is it nicer if I match? I was watching today's stream with Isaac talking about F#, and he said, well, in F# we don't use if else all too much. And then I looked at this file. I do use a lot of pattern matching, but there's also a lot of if statements. They're kind of nice when generating these list comprehensions and or everything else in here. So yeah, sometimes they're just easier, you know. So if we're talking about targets, F# when, so we're getting fancy in here. So when synchronous, then that just becomes the expression, and everything else well, target Fable, everything else is Okay, it does look nicer. Well, I should say everything else, right? Otherwise it was too specific. Alright, that's my wrapped returns. So now, another test. This should be gone, I think. I'm not sure. Yeah, here's another one. If I don't have a default response, then a default response is added, which is kind of cool. Okay, it was generated. That works. Yeah, the name of the function is still bad, even if it's synchronous. Well, I guess I could just error out when it's not good like this, right? The HTTP function. Okay, HTTP call. When is it called? Ah, there you go. Destruct expressions. So match config target with target F# when synchronous. Then we get this deconstruction. Deconstruct response. For all other cases, we get the deconstruct async response because this one uses let, and this one uses let bang, which we want. I think we're using just let. Yeah, it should be when inside async. It should be let bang. Okay, let's have another look. So far, so good. This is not like too complicated once you've got the base type, right? And yeah, I still need to add more of these and actually implement the runtime in here, but that's already, that's already pretty okay. And why it isn't adding the async? It should add async. It should add async in here. I already got most of the statuses. That's great. Okay, let's figure out why it's not returning async. HTTP func. Yeah. What about this func? I think it's in the client operation. There you go. Let's do this again. Match config target with target F# when the configuration is synchronous. Then do your thing. Otherwise, do that. And I guess we have it. F# synchronous, yeah, member name, and otherwise F# function async. I don't need those actually. If config target is F# is target F#, only add those when you have F#. Other than that, These are the open namespaces. All right, let's have a look. How did I fix the get from the HTTP library? I didn't. Thanks, Jason. See you around. I'm pretty sure I could use this code to get at least the path and the query string parameters, right? At least somewhat working for the initial implementation, because we have to still like encode the data in here in the query string parameters. But for the rest part, it's quite okay. Hey, we generated the project. I want to go back and see what it generates. Hey, it even compiles. So now the difference is that you will start with pet store client. You give it a URL, which will be the base path. And the base path will be combined with this partial path, operation path thingy. Numbers are changed. So now we no longer check for, okay, let me check that it compiles .NET build. So this is inside of the .NET output. It compiles, but that doesn't mean it will work, because of course we're still missing the HTTP runtime. I think I've said it a lot. It's still not implemented, but it's just one function to apply the method, the base path, and the parts, the request parts. But this is a good start. Definitely a good start. The types are not Fable specific right now, but there are things where they get Fable specific. Like sometimes you get JToken, but then it becomes an object instead of JToken, because JToken is a Newtonsoft thingy and not Fable thingy. Yeah, the rest look good. So this is another cool thing. So here, login user has a payload of string. If it's just a string, then you should get it back as is without any processing. Login user. Yeah, see, so login user, if you have a content, you will just get that content when status is 0. By the way, I didn't tell you that, but the reason I'm using integers here is because that's what simple HTTP returns. So simple HTTP works with the underlying XML HTTP request from the browser, and it returns you status code and response code if you just call it like this. Basically, this is the simplest way you can call it, but you could also have a more full-fledged request with all added headers and added method and content, etc. But we will take care of that later. For now, you can also have form data, which I think I will be using later to post files and things like that. But that's, again, that's for another day, because I think this was a good start. The generated code is already starting to look more Fable compatible. The packages, well, the included packages are Fable packages, so that's great. We no longer use anything from the system.net and system.http. We even don't need this. Maybe we'll need it later. Well, I guess if I use a resize array, do I have to open this thing? I don't know. I still need to check whether serialize and deserialize will work, but I think they will. I think it should be fine. Yeah, the rest of these helper functions can stay as is. And yeah, for the next part, I think that will be the HTTP runtime, this send async function. But I think that will be it for today. for next time, I think I'll start implementing the HTTP runtime. Maybe I'll just do it off screen and see how that goes. But I definitely want to, what I want next, and the next version, or basically the next release, is I want a Fable Feliz client application front end connected to a C# MVC. So I want a C# MVC that exposes a Swagger API and showcase that you could connect to it from Feliz quite easily. Let's go back to why. So yeah, so basically these samples, I'm adding more to them, and hopefully very soon I could also add ASP.NET Core MVC with Feliz or things like that. That would be quite cool, because so far with Fable it has been really good to have shared types with the backend, with the safe stack, but there are a lot of cases where you can't share types. So one of those cases, if your API is not written in F#, and that's the case a lot of the time with lots of systems, so there will either be some kind of REST API that is exposed by Swagger, and this is where we'll use Hawaii for, or it will be something like GraphQL, and we have Snowflake for that, and Snowflake already does all of these things quite nicely, so we don't have to do anything here. But that's all for the next time. Yeah, let's see how it goes. I hope we can get it working soon.